And we're back. Uh, we left off on this question number 4. So let's get started on this. For question part A, we let h be height above the ground, theta be the angle that the Ferris wheel is turned, and t be time. And t equals 0 is the lowest point of the rider, so theta is the angle from this vertical line right here, right? And the Ferris wheel is 5 meters above the ground, the radius of 20 meters, so the center is 25 meters above the ground, and this part of this triangle right here is 20 times cos theta, so the height is 25 minus 20 times cos theta, as we can see here. Theta equals 15t because the angular velocity is 15 degrees per second, so h of t equals 25 minus 20 cosine of 15t. And now we want the height of the rider 8 seconds after the wheel started turning, so we sub in t equals 8 and do the calculations, and we get 35 meters above the ground. Last thing is graphing composite functions. So the first step is there's 2 steps to approach this. First step is to simplify the function as much as possible, because if you end up getting a familiar function, then you'll have the tools you need to graph it. A function, i.e. a function that you've learned before. But if you do not get a familiar function, then you have to graph considering the graphs of the inner and outer functions, which is what I call graphical analysis. Example 1, I'll sketch the graph of y equals fg of x, given f of x equals x squared and g of x equals x to the 3. So we used the algebraic method and sub in x to the 3 to x to the 2, make a composite function. It equals x to the 6. This familiar function from like unit 1 or something, and looks similar to this. And you can sketch exact values, but I don't really care. Alright, this next question is this. You can pause the video and try it out yourself. So we sub g of x into f of x, and we factor the equation to get this thing. We add these to make one fraction inside each bracket, and then we multiply the 2 fractions to get this. This is a rational function, so you know how to graph this from unit 3. So we find the intervals which the function is positive and negative, and then we graph it. We sketch the function, noting the locations of the x-intercepts and the horizontal and vertical asymptote. Right, example 3, sketch y equals f of g of x given these 2 functions. Again, you have a few minutes to try this out yourself. Let's get into it. So we just sub it in, and we can't really simplify this any further, so we have to use graphical analysis. The blue graph is the graph of negative x squared, the graph of g of x, and we think about what happens if we sub these blue values into f of x. So for y equals 0, right, for gx equals 0, if this goes into f of x equals e of x, e to the exponent of 0 is 1, so we know we have a value of 1 here. These values are also decreasing, getting more and more negative, so if your exponent is getting more and more negative, then your output values are also getting smaller and smaller and approaching zero from above. And this is symmetrical on the other side of the y-axis because it's an even function. So it has a symmetrical behavior on the negative side as well. So you can sketch how the function looks like by thinking of how the function will behave when you substitute these values into the exponential. Final example, sketch the function given these two functions. You pause the video and try it out yourself. We'll get into it. So we sub this in and we first use a double angle formula on sine of 2x is here. Then we cancel out the 2 and the 1 over 2 to get cos squared x, sine of x over here. Now we factor out sine of x to get sine of x times sine squared x plus cos squared x. And this thing will equal to 1 because of the Pythagorean identity. And we simplify finally to log of sine of x. Now, the first thing we do is we note that sine of x is periodic, so we can really just do this for one period from like 0 to 2 pi, and then just repeat it for every interval of 2 pi. The blue function is the sine graph, and then we think about what happens when sine values get inputted into the logarithmic function. First of all, when you take a logarithm, you can only take logarithms of positive values of x. But since we're inputting g of x, or here, since we're inputting sine x, that means that sine x has to be positive where this function is defined. So right away we know that where sine of x is negative, the function is undefined. Now we focus on one period or one cycle from 0 to pi, since this part is undefined again. Now, at pi over 2, the sine of pi over 2 equals to 1, and the log of 1 is 0, so we have y equals 0 over here. From pi over 2 to pi, the values of sine of x approach 0. And when the input values of logarithm approach 0, the logarithm approaches negative infinity. So this composite graph will be approaching negative infinity. It will have a vertical asymptote. And from pi over 2 to 0, it also approaches, sine graph also approaches 0. So the logarithm will also approach negative infinity. So it's the logarithmic graph is basically we're going from like this, approaching negative infinity. So now this is one cycle of the logarithm of a sine function, and then you can just repeat it for each period of 2 pi, but note that there's nothing here. Yeah, it's the end of 8.3 composition of functions. Yeah, that's it. Yep. That's all I got. You can read the textbook for more stuff if you want to.